fellow scientists. My name is Jesse, and I'm a member of the Saskatchewan Science Center's Go Science outreach team. Today, we are going to be creating an explosive volcano using some good old-fashioned chemistry. Now, before we get to this molten hot experiment, let's think about what makes a volcano a volcano. On Earth, volcanoes are vents or fissures in the Earth's crust that allow magma, ash, rock, and gases to escape from underneath. When in the Earth, this semi-liquid rocks are called magma. When pressure is created, this magma can rise to the surface and erupt from the top of the volcano. After erupting, that magma is called lava. Now, volcanoes tend to become mountains because they're formed by that buildup of those explosive eruptions. Most of volcanoes that you would think about are called cinder cone volcanoes. These volcanoes are the ones that have that symmetrical cone shape. Now that we've talked about real volcanoes, let's recreate an eruption using just a few chemicals. Now, some of the chemicals that we're going to be working with today can be quite dangerous, so let me get my safety gear on, put on my safety glasses, and we'll get our nice black nitrile gloves on. All right, there we go. So, we don't want to make too much of a mess today, and we want to contain any chemicals that we are going to create or move around. So, I have this big old white tray right here. This is going to sit underneath where a volcano eruption is going to take place. And today we're going to use the following chemicals and materials. So the first chemical that we're going to be using today is 30% hydrogen peroxide. This hydrogen peroxide is lab grade. That means that it's 10 times stronger than what you would typically find at a pharmacy. Now, because it's so strong, it can actually cause chemical burns if we weren't careful. That's why we need to wear these nice gloves to keep our hands safe. The next substance that we're going to be adding to our volcano is going to be a little bit of dish soap. This is going to help us make our magma. We're going to add a little bit of food coloring to the volcano. This is so that we can see our magma and make it a little bit more like a real volcano. All right, we're going to use this big Erlenmeyer flask. This is going to act as the cone of our volcano. It's got that similar shape to what we talked about before. And then the last thing that we're going to be using to create our volcano, our last chemical, is going to be in this beaker right here. This is a mixture of potassium iodide and water. All right, so let's get started. First, we're going to keep our flask right here in the middle of our tray. That's so that way we can make sure we contain as much as possible. Next, we're going to add some dish soap and food coloring to the flask. So we're going to just dump those both right in there. We'll get all of our dish soap in there. We'll get a little bit of food coloring. We're going to add a little bit of food coloring just around the rim to make it like lava. Perfect. So our dish soap and our food coloring are now added. Next, we're going to add our hydrogen peroxide to the flask. Now, hydrogen peroxide naturally breaks down into water and oxygen gas. However, that reaction happens very slowly. Over time, this would just become water, but we want to speed it up. And to speed it up, we're going to add something called a catalyst to our reaction. So let's add that in there. All right. So catalysts are chemicals that help a reaction go much faster, but they don't actually get used up by the reaction themselves. In this experiment, the potassium iodide solution is our catalyst. All right, so I think we're all ready to go. We're going to make this volcano erupt. As soon as we add this catalyst, it's going to start. Okay, so 3, 2, 1. Whew. Got a nice reaction there. All right, well, that was really cool. Or should I say hot? That's right. Not only did we create a chemical reaction, but we also made an exothermic reaction, one that gives off heat. You can see all of this steam being given off by this reaction here. All that steam and all that foam is very, very hot. Now, just like a real volcano, the sloped sides here helped build up pressure and helped our magma get pushed out the top when that reaction took place. Well, thank you guys so much for joining us for this hot experiment. If you'd like, you can check out our other neat experiments by visiting SaskScienceCenter.com and clicking on the Real Science, Real Fun online button. Until next time, stay curious, fellow scientists.
Hey, how you doing? Tommy Tungsten here for Elephant Toothpaste with another super special sale. Hey, you smell something? Ah, must be another deal on sulfur. Now, sulfur gets a bad rap for being an accessory to all sorts of crazy things, like onions making people cry, the smell of rotten eggs, and you know, that thing that happens after you eat asparagus. But all these things, they only happen when sulfur runs with the wrong crowd. By itself, sulfur is odorless, non-toxic, and very important to life as we know it. You meatheads out there, you've probably heard of proteins before. But did you know that proteins is made up of even smaller stuff called amino acids? Well, sulfur is a key ingredient in making those little guys up, and those little guys make a lot of us up. Plus, the most abundant source of natural sulfur on Earth comes right out of volcanoes. Now that's a hot deal right there, folks. So why don't you come on down to Elephant Toothpaste and get yourself some sulfur. But hey, move fast, cause this stuff is selling like hotcakes. And when you get there, tell them Tommy sent you, capiche?
Hello everyone! My name is Sally Science, and I love it when you send in your curious questions for us to explore together. And today, we have an explosive question from Max. Have a look.
Hi, my name is Max, and today I have a question about volcanoes. Why do volcanoes get active and erupt?
Thanks so much for this wonderful question, Max. Would you believe me if I told you that rocks could melt? It's true! But before we talk about how rocks melt, let's talk a little bit about the Earth. Our planet Earth is not as solid as you might think. In fact, beneath the solid ground that you are standing on, there are other layers, and each layer gets hotter and hotter than the next. Huh, crazy, right? The ground is the first layer, and it's called the crust. It is very solid and made mostly of rocks. And then beneath that, there is a hot, gooey layer called the mantle. And then below that, there is a super hot liquid layer called the outer core. And below that, there is a super duper duper, I mean really, really, really hot solid mass called the inner core. Fun fact, scientists now believe that the inner core of our planet is as hot as the surface of the sun. Like a whopping 6,000 degrees Celsius. Wowzers! To answer your question, Max, we are going to just focus on the crust and the mantle. Now, the crust of the Earth is more solid than the mantle, but it is actually broken up into 9 humongous pieces called tectonic plates. The mantle is not quite as hot as the inner core, but it is still super, super hot, about 1,000 degrees Celsius. And that heat is enough to melt rocks into a hot, soupy material called magma. Fun fact, when the molten rock is in the mantle, it is called magma. And when it spews out onto the Earth's crust, it's called lava. Okay, let's pretend that this tabletop is the mantle, and these towels are the tectonic plates. So the 9 tectonic plates float on the surface of the mantle and move really, really slowly, like only a couple of centimeters a year. And one way a volcano can form is when those tectonic plates slide underneath each other and kind of bunch up to create volcanoes. And the magma. That's some hot science! So, a volcano is basically a gap in the Earth's crust that can let the magma and gases in the mantle out onto the surface. Now that we know what volcanoes are, let's find out why they erupt in the first place. This is an unopened pop can, and it is full of gas. And when I shake the can, I'm adding pressure and energy to the gas molecules in the soda can. And they're getting so excited, so very, very excited, that they just might want to burst out of the can to release the pressure. Wow, that was messy. Anywho, volcanoes erupt for the very same reason. Inside the mantle, there is a lot more heat and pressure than in the crust. And as gases create more pressure, the magma rises up through the cracks and gaps in the surface of the Earth, and blammo! Volcanic eruption! Fun fact, sometimes volcanoes don't erupt with lava. Sometimes it's just huge clouds of hot ash and gas. Thanks, Max, for sending in this awesome question. If you have a question that you would like to explore with me, please send it my way. I would love to hear it. I hope you all have a wonderful day, friends. And this is Sally Science, signing off.